This is going over the FIP quiz from yesterday. Today is 3/10/15. So this is your stoichiometry quiz, your first one. First question, we want to know how many moles of iron 3 hydroxide can be produced from the same mass of reagents that produced 1.75 moles of lithium nitrate. And I'm going to write the chemical equation first. Okay, so we're asked how many moles of iron 3 hydroxide, that's this stuff, can be produced from the same mass of reagent that would produce 1.75 moles of lithium nitrate. That stuff. Remember that you can do a mole ratio between any two things in a chemical equation. Any two things. So we're doing the same thing here we've always done. Start with our given, 1.75 moles lithium nitrate. And we know that we need moles of lithium nitrate on the bottom to cancel. What we want to end up in is moles of iron hydroxide. And we know that it's 3:1. So when we do the math, we end up with 0.583333, etc. moles of iron 3 hydroxide. And our sig fig answer, we can have 3 sig figs, ends up with 0.583 moles of iron 3 hydroxide. Okay? How many of you got that one right? Okay, on number 2, we're asked if 100 grams of lithium hydroxide react fully according to the reaction above, how many moles of iron 3 hydroxide will be produced? So we're starting off with our given 100 grams of lithium hydroxide. And we know that somewhere we need to make a quick note and figure out our molar mass of lithium. So what we get there is 23.95. And I tend, when I'm doing these kind of problems, especially a lot of them, I just glance through the problems and I immediately make a list of all my molar masses, just so I've got it. Okay, so I know that I need grams of lithium hydroxide here, and we want to know how many moles of iron 3 hydroxide will be produced. So we know we need to get into moles to get to our mole ratio, so that we can do moles of lithium hydroxide to moles of iron 3 hydroxide. Okay, so here we're going to have our molar mass, 23.95 grams of lithium hydroxide equals 1 mole. And for every 3 moles of lithium hydroxide that are used, we produce 1 mole of iron 3 hydroxide. So when we do our math, 100 divided by the quantity of 23.95 times 3, we get 1.39178848, etc., etc. We have 4 sig figs here, and this is, of course, moles iron 3 hydroxide. So with 4 sig figs, that's 1.392 moles FeOH 3 times. And there's our final answer. Okay, how many of you got that one right? Okay, so number 3, if you needed to produce 500 grams of lithium nitrate according to the reaction above, what mass of iron 3 nitrate do you need? So our given, and this one is mass to mass, we're going the whole way through, 500 grams of lithium nitrate. And so we know that we're going to need the mass of both the lithium nitrate and the iron nitrate. Okay, so we have our masses for the 2 compounds that we're working with here. We start out in grams of lithium nitrate, so we have to convert into moles. So we know we're going to have grams lithium nitrate to moles lithium nitrate. And from there we can go to a mole ratio. So we know we're going to have moles lithium nitrate to moles of iron 3 nitrate. And then we want to know what mass of oops, yeah, okay. We want to know what mass of iron 3 nitrate we've got, so we know that we're going to want to go from moles of iron 3 nitrate back to mass of iron 3 nitrate. Okay, so we can fill in numbers. That first box is just the molar mass of lithium nitrate. Remember, check yourself to make sure that each box, when you're looking at a vertical box, is a true statement. So is it true that 1 mole of lithium nitrate is 68.95 grams of lithium nitrate? Yes. Yes. If the statement is not true, so like if you had switched those numbers and you were saying, oh, 68.95 moles of lithium nitrate weighs 1 gram, that should set off a bell in your head. So, but I literally, I will go through and check myself because I flip them sometimes. Okay, in the next box we want a mole ratio. So for every 3 moles of lithium nitrate we produce, we need 1 mole of iron 3 nitrate. And we're, again, getting those numbers straight from our mole ratios. And then our last box is, again, just a molar mass. So 1 mole of iron 3 nitrate is equal to 241.88 grams of iron 3 nitrate. Okay, so when we do all of our math, we get a raw answer of 584.6748852 grams of iron 3 nitrate, and we have 4 sig figs, so we get 584.7 grams of iron 3 nitrate as a final answer. Okay? So now we have a new reaction that we're working with. Potassium iodide reacting with lead 2 nitrate, forming lead iodide and potassium nitrate. Good stuff. So we've got 24.5 moles of potassium iodide. And we want to know what mass of lead 2 iodide we can produce. So since we're already in moles, we can go straight to a mole ratio. Moles of potassium iodide, and we're looking at the lead iodide. Moles of Pi2. We want to end up in mass of lead iodide, so moles of Pi2, grams of Pi2. So our mole ratio is a 2 to 1, and we need the molar mass of lead iodide, so we'll take a break and do. Okay, so we know that 1 mole of lead iodide is 461 grams of lead iodide. So when we do our math, that times 24.5 divided by 2, we get 5,647.25 grams of PBI. I was making phosphorus iodide there earlier. Sorry. So we have 3 sig figs to work with. That's going to get us 5,650 grams of lead 2 iodide in round numbers. How many of you got that one? Okay, good. Actually, question was, what if we had something where there were 2 moles of this stuff in the equation? Would we use 461 over 2 moles, or would we use 461 times 2? No, because this number is strictly the molar mass. So we're saying there are this many grams of this stuff in 1 mole of this stuff. And that's regardless of how many moles are reacting or how many moles are running in the equation. So yeah, regardless of any of that, that's always to 1 mole. Okay, so the question was, could you scientific notation that? You could, but you'd have to be careful, because with scientific notation, remember that, everything that is shown in scientific notation is significant. So if you write this in scientific notation to have 3 sig figs, you have to do that. Okay? If you go to do scientific notation and you leave it like this, That's wrong. That's the wrong sig figs. Okay? Because that 0 is now significant, because if you show a 0 in scientific notation, it's significant. So that would not have the correct number of scientific or significant digits. This would. Okay? Okay, so this is another mass to mass. You need to produce 500 grams of lead-2 iodide according to the same reaction we used in the last problem. What mass of lead nitrate do you have to put in? So we're starting with our given as always, and we know that down and to cancel will be the same unit, same chemical, and we need to get this into moles. So now once we're here, we're in moles, we can go straight to our mole ratio. So we know we're going to have moles of lead-2 iodide, and we want to know what mass of lead-2 nitrate is needed. So this will be moles of lead-2 nitrate. And our mole ratio is 1 to 1. That's easy. Now we're in moles of lead nitrate, and we want a mass of lead-2 nitrate. So I've gone ahead, I've got both of our molar masses figured here. So once we get our stuff set up, we're ready to pop those in. So we'll work with our lead iodide first. We figured this molar mass in the last problem. So 461.00 grams of lead iodide equals 1 mole of lead iodide. And for lead-2 nitrate, 331.22 grams of lead-2 nitrate equals 1 mole of lead-2 nitrate. So now we do our math. So we get a raw answer of 359.2407809 grams of lead-2 nitrate. We have 4 sig figs to work with. So 359.2 grams of lead-2 nitrate. Okay, how many of you got that one right? Excellent. That's it. We'll talk a little bit more about this and the schedule for the day. No.